Here we will consider the Newton's first law of the motion. But before we state the Newton's first law of the motion, we will consider the simple example. Let's suppose this is the book, and the book is laying on the table, and here I consider that this book will remain at rest. This book remain at rest it will be at rest. Now, if I push this book with a horizontal force, like this one is the force, now I am applying the force on this book. There is the force of friction between book and table. There is the force of friction between book and table. Now I apply the horizontal force and push the book, and in order to overcome this force of friction between book and the table. Now there are the two types of the applied forces. Now the applied forces here are there are the two types of external forces. Number one is the applied force, and second force is the force of friction. Second force is the force of friction. Both these are applied external forces. These are the external forces, and when you apply the force on book, and by applying the book you can keep the book in motion. Okay, when you apply the force on this book, you can keep the book in motion by applying the force, which is just equal in magnitude to the force of friction, but in opposite direction. Okay, how you can keep the book in motion? How you can keep this book in motion? This book in motion. Okay, book will move until you apply the force. Apply the force. And this force must be equal in magnitude to the force of friction. To the force of friction. And this applied force must be in opposite direction to the direction of the force of friction. If you are applying the force, applied force is in this direction, then frictional force will be in the opposite direction, and this frictional force try to retard the motion, try to stop the book from moving. Okay, now let's suppose now you push the book, and now you apply a push on the book hard. Okay, if you push the book hard, then what will happen? If you push the book on hard so that the magnitude of the force exceed the force of friction. Now the magnitude of the force, magnitude of applied force, magnitude of applied force exceed the force of friction. If it exceeds the force of friction, the book will accelerate. As a result, book will accelerate. Okay, again I can make the figures like this one. Suppose this is the table, and here the book is laying on the table. Now you are pushing hard on this book. You are applying a greater force which exceeds the force of friction between between table and book. Now the book will accelerate. Now book will accelerate, you can accelerate it in the forward direction. But when you stop pushing the book, now stop, if you stop pushing the book, then what will happen? Then after covering a short distance, the force of friction will overcome, and as a result the book will be stopped. Okay, what happened? If you stop pushing the book, if you stop pushing, the book will stop after moving a short distance. Okay, if you stop pushing the book, then book will stop after covering some distance. Okay, it will be stopped after covering some distance. Why it will get stopped? Because now the force of friction retard its motion. Now force of friction is now comes into action, and it stop the motion of book. Again, okay, now we perform this experiment in another way. Now if you push a book on a smooth surface, okay, if you push the book on smooth and highly waxed surface, smooth and highly waxed surface. Now what will happen? If you are pushing on it highly waxed and the smooth surface, again book will come to rest. Why it will come to rest? When you are pushing on the smooth and waxed surface, it will come to rest, but not as quickly as before. Okay, now it will cover some distance larger than the distance as you applied the force when book was on the harder surface. Okay, when the book is on the polished surface or smooth surface, still the book will be stopped by the force of friction, but it will cover a distance larger than before. Okay, now we can repeat this experiment by another way. Now let's suppose you are pushing the book on the polished and frictionless surface. Okay, now push the book on frictionless surface. Okay, now this is the table, and here this is the book. Now we suppose that now the force of friction is equal to 0. That's the surface is highly polished surface because there is no force of friction. Now there is no force of friction, and so in such a case you can keep the book into the motion. It will move until it hit a wall or any other type of obstacle. Let's suppose this is the wall. If book hit the wall, then it will come to rest. Otherwise it will be in the motion because there is no force of friction. Just you need to set it in the motion by applying the force, and after that the book will remain in motion if there is no force of friction to stop the book. Okay, we have performed this experiment in 3 different ways. First, you push the book on the harder surface, and in that case when you apply a force when you apply the force greater than the force of friction, in that case when your applied force exceeds the force of friction, book will accelerate. But when you stop pushing the book will get stopped. And in another experiment, when you push the book on a smooth and highly waxed surface, in that case the book will move larger than the harder surface, but still the book will get stopped by the force of frictions, because after some time force of frictions comes into actions and it can stop the book. But when we repeat this experiment with the highly polished and frictionless surface. Frictionless surface here means that there is no force of friction. Now the force of friction is equal to 0. When there is no force of friction, you can keep the book in motion just by applying a small force until uh, it come to hits the wall or any other kind of obstacle on its way. Okay. Until 16th hundred of century, and there was until the 1600, then the scientists believe on the theory that scientists believe that the natural state of the natural state of matter is state of rest. Until there was a scientist whose name was Galileo, and Galileo was the first who takes the different approach to the motion and the natural state of the matter. And he said that he said that it's not the natural state of rest is not the natural state of the matter, natural state of an object come to rest once it's set into the motion. Rather, it is the nature to resist the change in the motion. Okay, what he said, it says that the nature state of the motion is not the state of rest, rather it is a nature state of the object is to resist the change in motion, in its motion. Everybody tries to resist the change in its motion. For example, let's suppose this is an object. Once you impart impart the velocity to an object, okay, by applying certain type of the force, you set it into the motion, then the object will rigidly maintain its velocity as long as the external retardation or frictional forces are removed. Okay, if there is no force of friction, then this object will try to maintain its state of the motion. So this was the approach of the Galileo. And so Newton used this new approach, and he gives us the Newton first law of the motion by using this approach. Newton first law. Newton's first law states that, what he states? He states that, okay, Newton's first law states that in the absence of external forces, in the absence of external forces, when there are no external forces like frictional force to stop the body is present to retard the motion of the body, in the absence of the external forces, an object remain either at rest. Object, if it is at rest, the object will remain at rest, and if it is moving, if it is in motion, then the object motion continues. Object motion continues. Okay, and its motion is moved with the constant velocity. Moves with constant velocity. Okay, Newton's first law states that in the absence of external forces, if object is at rest, it will remain at rest, and if it is in motion, the object will continue its motion and move with the constant velocity. So it is Newton's first law of motion. Okay. In other terms which is related with the Newton's first law is the term inertia. So what is the inertia? It is the tendency of the body to resist any change in its velocity is called inertia. Okay, that's why the Newton's first law is also called as the law of inertia. Because any object try to maintain its state of rest or its state of motion. So it is called as the law of inertia because the inertia is the tendency of the body to resist the change in its velocity. Okay, if body is moving, it will try to maintain its motion. So this is the that's why the Newton's first law is also called as the law of inertia. Okay, now we will consider some examples of the Newton's first law of the motion. Here, this is an example of the air hockey game, and here you can see that this is an example of the constant motion on nearly a frictionless surface and motion of this light disk on the film of air. And if the disk is given an initial velocity, it will cover a great distance before stopping. So this is an air hockey game, and air hockey this game has taken the advantage of the Newton's first law to make the game more exciting. And okay, then another example is the example of spaceship. Spaceship, you know that it required some propulsion systems to change its velocity. However, if the propulsion system is turned off when the spaceship reaches a velocity v, then the spaceship will move at constant velocity and astronauts can get a free ride. And so because there is no propulsion system is required to keep them moving at some constant velocity. So these are the examples or the applications of the Newton's first law of the motion. Thanks for watching. For more videos, please subscribe our channel.